So I'm going to give you an overview of network security, and these are important things to talk about anytime we talk about networks. One of the things that's happened in the last few years is that there have been just an increasing number of attacks. And so why is that? Why are there so many attacks? And the number one reason that there are so many attacks, there's actually two. One is there's more and more information that is being placed online, accessible always online. And so as more information gets to be accessible, then it becomes the attack surface, which is what we call the basic exposure of some data. That exposure is usually constant, and so the longer that device or service is exposed to a potential breach or an attack, the more opportunity that there is to actually carry that out and for it to be successful. So we're going to talk about just some things, some different types of attacks, some different types of threats, actors, threat vectors, exploits, vulnerabilities, and those types of things. Some of this terminology you have no doubt seen before. You will, of course, see it again. This is something that you will always want to keep in mind and work through. So we'll also look at what type of things that we'll classify as an actual attack on a network. We'll look at how we could possibly mitigate those things in the terms of network devices. So there's lots of software that we could put in place, but we're going to look at network devices specifically. And we're going to look at, lastly, how to actually configure those devices. So the types of threats that we have is mainly you have an attacker that has a specific task in mind. They either want to cause some type of data loss, or they want to manipulate some data. They want to, what we would call exfiltrate. When we say we want to infiltrate something, we're going to get into it. When we exfiltrate, we're actually taking things out of the network without being detected. So when we infiltrate, we want to ingress into a network undetected. And the whole purpose is to either move laterally into another system or to exfiltrate data outside of the system. And then finally, perhaps we just want to disrupt service. We want to cause some confusion, possibly. We want to test defenses. Many of these things can and do happen, and some of them often simultaneously. So there is what we call the hacking cycle, and there is an actual specific cycle that takes place. So when a hacker gains access to a system, in order to do that, in order to gain access, that attacker has to actually go out and do some investigation. He has to do some reconnaissance, and then in order to find out what type of system is out there, what type of hardware is out there, what type of software is running, and then I have to actually figure out what type of what's called an attack vector that I'm going to use. But what kinds of different things could we do, right? And so there are different vulnerabilities or weaknesses. There's vulnerabilities in the TCP network protocol. For instance, I may respond to a particular ping request or an echo request, and they send an echo response that tells the attacker that my service is up, operational. It also tells it the IP address. Once I actually communicate with that device, there may be a service running, a daemon service that's running, and that actually responds to the request. And that response is an actual banner message that comes up that we see. Just like when we connect to a switch, we set the banner message, the message of the day. We set the warning message. Right? When we do that, we're giving a response to whatever signal is received on that device. So in a closed network, that's not that big of a deal. Right? I want to be able to see that I have a switch that actually responds to me. There's something active there on an IP address. On a network that is facing the outside world, or the routable internet, I definitely don't want to always respond to every request. Because if I did that, if I responded to every request, then I would, first of all, be using system resources to do that. It may not seem like it's a big deal, but when you start seeing lots and lots and lots of attacks over and over and over, hundreds of thousands, for instance, millions of packets per second, all hitting a particular service or device at the same time, that particular device or service can no longer handle the load that is placed upon it, and it fails then to respond. Or even worse, it could turn, if it's a switch, for instance, it could turn into a broadcast network. Right? There's other vulnerabilities. Was there an access control that wasn't applied? Was there a software or hardware change that didn't follow a policy? All of these things can combine together and stand apart, of course, to make something vulnerable. Right, so these are different types of threats that we have. Hardware threats, physical damage. Right, I could actually go and cut a fiber line. Right, there was a good story of that is a fiber was cut in a field in Nebraska. Shortly thereafter, Chicago O'Hare International Airport air traffic control went down. And they were down for quite a while. Because it wasn't like there was a fiber in the city that they could just rush over and get the splicing gear out and go ahead and make another connection for the 48 fiber optic cables that were inside that device. They didn't have that ability. Instead, they had to actually wait and bring out a mobile thermal splicing unit. It takes several days for that splice to actually cure before they can turn the fiber back on. So lots of time gets spent in a physical situation, and more we see physical damage causing issues. There was a recent issue of someone who, an activist actually, that was able to get in and terminate or cut a fiber line that was running into a Google data center. And that just causes so many problems when that happens. It's a physical cut, and there is a lot of stuff that has to be done in order to get that resolved. We also have environmental threats. So what happens when the temperature in an environment gets too hot? Even in Longview, several years ago, we had a summertime it was very hot. It was essentially above 100 degrees for a couple days, And during that time, I used to actually work for Alltel customer service. And one of the things that happened is that what we call the switch, right? We called it the knock or the switch, which was really a massive data center, not just a single switch, but a massive data center with cell towers, with batteries, with power, with all kinds of switches, computing gear. They called it collectively the switch, but it was a huge facility. And what happened is the air conditioning failed, and it was a cascading failure. The outside ambient air temperature got in the plus 100 degrees. A main air conditioning unit failed. It caused the temperature in the environmental system to increase. That caused a cascading failure on the AC. Eventually, within a few minutes, there was so much heat being generated that they had to do a controlled shutdown of all of the systems. And in order to do that, they had to actually take the systems down in a particular order. They had to actually take down the power supplies, and it was just a total cascading failure that was caused because each air conditioning unit, and there were many in that facility, it just began to fail. It could not handle the load that was placed on it. I went to visit a particular site in the spring, and these folks that have a lot of servers in their data center, and they had just added about 20% more servers, but what they found out when they did that is that their air conditioning and cooling system could not handle the heat load. And so they were in the process of actually buying an expanded air conditioning unit, and it was going to be 2 weeks before they could actually get this unit out and get it installed. So what they decided to do was basically bust a hole in the wall and put a fan in, and it would suck air through the building and blow it out the wall. But what they figured is that it would be cheaper for them to patch the wall once they got their big air conditioner in than it would be to lose the revenue they would lose if their systems went down for even a matter of hours. So those types of things are serious issues. And another thing, critical spare parts. If you have a lightning strike, or if you have a critical parts failure, how many days is it going to take you to get a part in? There were situations where it was in the wireless internet business, it was easy to stock spare parts on some things, but there were other things where this particular gear, maybe one component was $10,000 to $12,000, and then you had to install it in a specific way. There was no way we could keep backups on all of that particular types of equipment. So we had to prioritize what could go down, how long could we stay up in the event of an outage of a critical component that was too expensive to have a backup on hand. The other side of that is I worked with a gentleman who I was the consultant for, and he had a backup for everything. He had $100,000 worth of network equipment in operation, and he had $100,000 in exact backup equipment available in that facility as well. So you have multiple systems that are set up, and that's another way to go the other direction, right? So you have so much invested in your backup that you're actually wasting resources. Anyway, we got to look at all those things when we look at it's not just the hacker, it's not just the cracker, it's not just the social engineer or the person that exploits a vulnerability. It is the physical systems as well. But we're going to look at network attacks. So what happens in a network attack? Right, so malware, or malicious software, is actually designed to damage, disrupt, steal, or inflict a bad action on data hosts or networks. So some different ways that can happen. One of the most common ways that not necessarily listed here, but more and more common is ransomware. This ransomware gets on a machine. The attacker will encrypt the data. They will demand a ransom in order to provide the encryption key or the decryption key. People are encouraged not to pay the ransom, but they're asked instead to either just start over from scratch or utilize data that they've backed up. So hopefully there is a backup. But this virus spreads from one computer to another. Now, one of the things that can prevent spreading of viruses is good policy control. So if I can implement a good policy that will secure my system, I want to make sure, for instance, that nobody is running a machine on the network as a local administrator. Right? That is the problem. And it actually will facilitate a lateral movement when a system or a device gets infected or impacted by a vulnerability. At that point, my attacker can escalate privileges, and he can have the ability to run code or data on my system. And what he's looking for is the opportunity to move laterally to another system. We call it lateral movement. Now, a virus is just going to use whatever means of spreading that it can. So perhaps one of the most well-known viruses is the I Love You. And that was also a worm. But basically what happened is that it would spread via email address book. So I would create an email. The virus would actually use a macro and make a new email. And it would send out a message to every entry in the address book. And that email would actually contain an attachment. And that attachment was a small little script or an executable file. And when that executable file would run, that program would actually create a new message, address that message to all of the people in the recipient's address book. And that is essentially a worm. It doesn't, in this case, the I Love You virus was a virus just because it did require human intervention. I had to click on the attachment, but that doesn't mean that I'm always going to have to do that. And I don't always have to click on the attachment in order to make a worm propagate. One of the things that's happened in recent years is that, and especially since Windows hosts actually made it capable of running in a lower security mode, it helped prevent the ability of things like worms to spread through computer to computer in a very fast way. So basically, what would happen with a worm is that there would be some code that would be sent over. The code would actually automatically run. It would then grab this worm file. The worm file would run the script. It would execute. It would replicate itself. It possibly put itself out onto the network, or maybe even send itself an email, generate some type of application where it could easily move from one machine to another without any intervention. One example that happened very commonly in the old days when there was removable media is that as people would pass around particular disks with software on them, they would actually put the disk in. The first thing that the disk drive would do would be to scan to an actual file allocation table on a disk, and it would read that file allocation table into memory. What would really happen there is that file allocation table would have a little program that would run, and it would cause some code execution in memory. And one of the things that it would do when it actually executed the code is that it would wait for you to put in a blank diskette, and when you wrote the file or saved some information, it would actually go on the diskette. You would never even know it because it would actually sit inside your RAM, and it would wait for you to do that thing. And so these were extremely small viruses originally. But they began to grow in sophistication. Another thing that was happened is a Trojan horse. So a Trojan horse could be a virus, but it doesn't have to be. If many of you took my IT security class, one of the things that we did in that class was we actually created a Trojan horse. If you remember, what we did was we actually used an application that was a legitimate application installer that was a little word processor. It did not have a virus in it. What it did have was a wrapper file, and so I would take that executable file, and I would actually hide some code inside the executable, so that when I ran it, what would happen is while I was being presented physically with the installer and being asked a series of questions about whether I wanted to install the file, in the background, all of the files in my documents folder were being deleted. And you could also do the very same thing where you encrypted those files. All right, and then so the idea is that once I have access to do something, I can do something else, and something else, and something else. And so essentially what happened is, in that particular case, is I went to install this legitimate program. It was a perfectly legitimate program. It was going to take a good 3 to 5 minutes probably to do an installation for the user. They were going to be asked some questions, and they were going to click through and go ahead and proceed with the installation. By the time they actually answered the first question in the installer, their files were gone. So by the time they finished installing the program, their entire documents folder becomes deleted. And it was a deletion that was unable to retrieve the file. So it was a permanent deletion of the files. And so again, perfectly valid software installation, but a hidden bonus. The file gets deleted, and you are none the wiser. All right, so that's what happened with the Trojan. And very many Trojans happen the very same way. You never know what hits you. So those of you that actually did that lab, you know that it is real. So here is what we talked about earlier. There's some reconnaissance that's done. I have to go out and actually do a scan. I have to do some in what's called a numeration. I'm going to go and actually look for all the hosts on the network. I'm going to look for all the IP addresses. I'm going to find out what systems are where. I'm going to trace down as many open source intelligence sources as possible. All right, and then access attacks. What can I do? How can I get to the data? How can I erase it, encrypt it, change it, override it, read it, exfiltrate it, erase it, change it, okay? And then can I disrupt? All right? Can I disable, disrupt, overpower, or make it to where there's not enough resources? Okay. So NSLOOKUP and WHOIS are two utilities that you could use. In reality, there are many, many, many other utilities that could be used to do investigation, to find out information from public database sources. One example of that is Twitter. Twitter is a public data feed, so I can find out using particular Twitter searches all of the people that work for a particular company on Twitter. All right, so now I have their Twitter handles. I have because I have their Twitter handles, I can now look up the history of all of their tweets. I can do that in an automatic way, and I can pump it all into a database. So then I can go and look up the actual people, the things that they do, what their job functions are. I can maybe go and look for some email lists or some phone lists, or I can go in and try and basically map that information into a listing. And each time I get a piece of information that can link to something else, I have built more and more information on top. And so I begin to run a profile of that organization, and I can look and see what hosts are there and how everything works. So here is a network attack, right? How are we going to use this as an access attack? So I'm going to try to do a couple things. First thing is, I'm going to try and break some passwords. All right. I can brute force it. Brute forcing means I'm just going to try over and over and over and over again. How many times can I try the password? Right. Another way is perhaps I know the encryption scheme of the password and I just want to try and crack it. Right. Using a hash technique or some other tool. So trust exploitation. I could use, maybe I steal the password from somebody. Right? Maybe I actually crack the hash. Right? I have, at that point, unauthorized privileges, so I can then move and actually exploit trust. Maybe I know somebody, and I wrote down their password, right? And I can log in as them. That's a trust exploitation. Okay, and so the next one is port redirection. So here's an example. The threat actor uses SSH, which is port 22, to make a connection onto a compromised host. Host A is trusted by host B, and therefore the threat actor can use Telnet to access it. That is actually a realistic example. One of the things that I might tell you, and that I will tell you, is never use Telnet. Unfortunately, that's not necessarily a realistic example. There could be devices that have Telnet on by default. One of those devices is a Cisco switch. It has Telnet on by default. There are many other devices that have Telnet on by default. If I can use some credential that I have lifted off of a target, or maybe I've tricked somebody, or I've busted a password up, or I've tricked somebody to give me their password, I've used that trust exploitation, to get into an SSH connection, which that's a big deal, If I can break into an SSH connection, I have actually gotten really far at that point, because that is a trust barrier. And the next thing, okay, so I'm going to find at that point some equipment that's out there that has port 23 open, and I'll open up a telnet connection. Telnet, as we know, is unencrypted, right? I don't have to do any type of handshaking. I don't have to do any key exchange. I just open the connection and start sending data. Now, there's a good chance that if I'm using that unencrypted or open connection, and I'm using the telnet connection, that I'm going to have some default passwords in that system somewhere. Or maybe I don't have any passwords at all. So, man in the middle. If I can somehow trick my device to send data to me, or if I can somehow trick a device to send data to me, and I'll just go ahead and make a copy of it and forward it on to the person that actually intended to. The only thing that the person should notice in most cases is a little bit of delay. And maybe not even that much delay. It could be negligible, depending on where that system is on the internet. Now, what will happen is that you will essentially see a fingerprint on an SSH key, and it would say, okay, this looks different than what I've seen before. And in SSH, when you connect to a host, what happens is the public key for that host gets placed in a file called known hosts. So I'll show you an example of what that looks like. When I go to SSH, this is PuTTY. This program is called PuTTY, and when I look at that, I have some hosts here. Now, this particular host is telehack.com. So when I look at that and I load its profile, I'm actually telling it to go into port 6668. Okay, and I'm going to use SSH. Now, I've already given the telehack server my public key. So the reason why I do that is I'm giving it something to send to me so that I can verify that yes, it indeed is the public key that I've given it. And I'm going to go ahead and decrypt that key with my private key, which I created using the key pair, or a key generation, and I can go ahead and create a connection, and that connection is completely encrypted. If I use the telnet port, I'm just going to click cancel here, and I'm going to go ahead and put it on telnet 23, and this is an unencrypted communication. So I think what we'll do here is I will show you the difference. Not doing too good here. I'll have to come back to this in a quick little lab I'll do after this video. And I'll show you the difference between an encrypted and an unencrypted communication, and also what would happen potentially if there was a man-in-the-middle attack. But then the next thing we have is a denial of service attack. Essentially what happens with the denial of service attack is I am sending, or I'm causing to be sent, enough connection requests that that the remote system is overwhelmed. Either it cannot keep up over the load, and it just begins to shut down, or it can no longer function, or I am sending a packet of data or a piece of data that's too large for it to handle. So what happens is denial of service attacks can cause interruption of communication channel. One of the largest denial of service attacks was ever recorded. Was multiple terabits of traffic at one time. And the problem with these large denial of service attacks is that for the person that actually generates the attack, he can utilize all of its resources to send that attack over, or he can use the resources of millions of hijacked hosts to do his dirty work for him. Now, the problem is that if that denial of service attack is actually coming from all over the internet, the problem is, how do you filter to stop the traffic coming from that one device? What you ultimately have to do, especially if the traffic is coming from all types of different sources, is you have to just take that particular IP address down. And so if it's a critical piece of information in terms of if I'm using that address to route a lot of traffic, that device goes down. It can't run anymore until we get it back up. So I could send out a massive stream of data and cover a whole range of IP addresses with my denial of service attack. And essentially, there's nothing that the internet provider can do except at some point in the network, they would have to actually utilize some other resources to accept all those requests, and effectively just works just like a lightning rod. Requests come in, it works like a lightning rod. It shunts them to ground. It basically drops all the packets. The problem is it takes up massive amounts of resources in order to do that. The benefit is the resource that actually is being protected stays online. So one of the ways that happens is botnets. I go out and I infect lots and lots and lots of hosts with a little piece of malware, and it is designed to do one thing only, and it's designed to send out packets. And it could be designed to send them out in a huge burst. It could also be designed to trickle them out very slowly. It depends on how big my botnet is. If I have millions and millions and millions of hosts, I don't need each host to send a whole bunch in order to overwhelm my target. Okay, so we're going to do a little bit of labs here in the next video. And then we'll talk about mitigation.